the presynaptic that sends the message through the synaptic gap into the postsynaptic dendrite. So during resting potential on the outside of the cell, the charge is more positive, and then the inside of the axon, the charge is more negative. During depolarization, sodium ions flow through the sodium channel into the axon, which makes the cell or the charge inside of the cell more positive.
At the same time.
During repolarization, the potassium ions flow from inside the axon to the outside of the axon through the potassium channel. The charge of the axon is now negative, and the charge outside of the axon is now positive. After repolarization, hyperpolarization is when there's too much potassium that flowed outside of the axon, which makes the inside too negative. During recovery, the sodium ions flow outside of the cell using ATP because it's against the concentration gradient, and the potassium ions flow back into the cell.
We're having issues with this thing.
This is a good video.
Until they are all back in their normal spot, and then we'll show. After the signal has traveled across the axon, it triggers the calcium channel to release calcium into the cell. This goes into the calcium receptor, which changes the charge of the vesicle and causes the snare proteins to bind to each other. After the vesicle has been opened, the neurotransmitter acetylcholine flows into the synaptic gap and binds to the receptor. The receptor then opens, allowing sodium ions to flow back into the postsynaptic, which triggers action potential to happen in this neuron.
Oh shoot. Yeah.
Okay, reuptake is when used neurotransmitters go back into the enzyme and they are transported back into the original axon.
Okay.
Nicotine binds to the receptor of the cell, which makes it constantly stimulated. So sodium constantly is flowing into the cell. Serine blocks the enzyme for reuptake, so the neurotransmitters stay inside the synaptic gap, which also constantly stimulates the cell.